So today we're going to discuss graphs of quadratic functions using completing the square form. And we're going to look at examples that are just to do with minimum turning points today. So when we use completing the square form, doing this makes it much easier when it comes to sketching graphs. Using this form, we can easily identify turning points of the graph and also the axis of symmetry. And we can identify those two things simply by looking at the equation in completing the squared form. So if you have an equation that we're trying to sketch a graph for, by putting it into completing the square form, it makes it much easier to sketch these graphs because we can easily identify the turning point and the axis of symmetry. So let's look at this first example. The parabola is the graph of the function in the form y equals x minus a all squared plus b. Find the equation of the parabola. So here we've got a parabola, and you can see that the turning point when it turns its direction and goes straight back up is 3, 2. So at 3, 2, that is the minimum turning point. It's the minimum because it's going down to the minimum point and going back up. You know that the standard equation of y equals x squared is a standard parabola starting at the origin 0, 0. Okay, so y equals x squared is 0, 0. We're going to go through a few little steps to see how we get the equation of this parabola by simply moving our original graph y equals x squared. So if we were to move it 3 places to the right, okay, because we're aiming to get to this turning point, if we move 3 places to the right, our x value has been moved by 3 places. So we've replaced the a with 3. And then we're going to move it 2 places up the y direction. That's why we've got plus 2 on the end. So starting at our standard y equals x squared, we've moved it 3 places to the right. So we've replaced our a with 3. And then we're moving it 2 places up to get to our turning point. So our equation is y equals x minus 3 squared plus 2. So this is in completing the squared form. And now I'm going to show you how to pick out both the turning point and the axis of symmetry. So to pick out the turning point, this term here, you're going to change the sign to get 3. And the last term for b, you're just going to leave as is. So change sign, leave alone. And then you can see that a and b are actually the turning point. So turning point is equal to AB. And then the next thing that I said we could identify was the axis of symmetry. So the axis of symmetry, straight down the middle of your graph. So if you were to imagine to fold that graph over and it was to lie directly on top of the other side, straight down the middle, x equals 3. Because all the way up that line, x is always equal to 3. And that is your axis of symmetry. And you can see that 3 is equal to a. So axis of symmetry, x equals a. This pink box down the bottom is the most important bit, and you need to know where a and b come from and how to pick it out of the equation of the parabola. Let's look at another example. So again, the parabola is a graph of a function in the form y equals x minus a squared plus b. This time our turning point is -1, 3. And it's a minimum turning point. So starting from your standard y equals x squared, it's moving back -1. That's why we've got +1 here. Because our original function, if you look up the top corner, x minus a, okay, and if we're going back 1, a is -1, this becomes a plus. So although that's a plus, you'd think it would be moving forward, but try to think of it as your standard form is minus a, where a is -1, which makes this a plus. So if there's a plus there, it means it's moving back to the left. So we're going back -1, and then we're going up 3 places to get to where our turning point was, and that is how this equation comes about. The x value is moving back 1 and the y is moving up 3 places. So this is our equation, and let's think about picking out our turning point from our equation. I know we already know it, but we need to know where these numbers are coming from within our equation. So we have to change the sign of the +1 just to get -1, that is your a, and then the last term you leave it alone to find b. So we're picking out our a and our b here. So a is -1, b is 3, and because we know turning point is a, b, that's our turning point here. And then to pick out your axis of symmetry, drawing a line straight down, x equals -1, but we know that the axis of symmetry, x equals a. So because we know a, we already know that the axis of symmetry is x equals -1. Okay, example 3. Again, this parabola is the graph of a function of the form y equals x minus a squared plus b. Find the equation of the parabola. Okay, so we know the turning point is 4 and -2. Okay, so 4 and -2 is the minimum turning point, which is a and b. So what we're simply going to do is we're going to replace 4 and -2, substitute it into our equation here. So we're just going to replace the a with 4 and replace the b with -2 to get this. So y equals x minus 4, we've replaced the a, minus 2. So again, if you were working backwards, change the sign to get a, leave it alone to get b, and we can see that it is right enough. Our turning point 4, -2 is correct. And then to find the axis of symmetry, x equals 4 straight down the middle, which again is a, x equals a for the axis of symmetry. Okay, example 4. This time we're just going to work straight with the equation and pick out the turning point from the equation. So identify the turning point of the graph. So we need to find out what a and b are. To find a, we're going to change the sign of this term here. So it's +5, so we're going to change the sign to get -5. And then to find b, we're going to leave that last term alone. So which makes our turning point -5, because we've changed the sign, and -2, which is the minimum turning point. Identify the axis of symmetry. Well, down the bottom here we know the axis of symmetry is x equals a, and we know a is -5, so x equals -5. So here we've picked out the minimum turning point by changing the sign, keeping it the same. That is your a and your b, which makes your turning point, and your axis of symmetry is exactly the same as your a value. Okay, so I would like you to try these 4 questions. So if you pause the video here, down the bottom there is little hints to help you. Remember, your turning point is a, b, and the axis of symmetry is x equals a. Make sure you've got this box copied down into your jotters as well. And so I would like you to, for the following functions, I would like you to identify the turning point and also the axis of symmetry. So if you pause here and give them a go. Okay, hopefully you've unpaused now. Okay, so the first one, y equals x minus 6 squared, add 2. So to find a turning point, we need to find our a and our b. So we're going to change the sign just to become 6 to find your a, and leave it as it is, as 2. So your turning point is 6 and 2. So minus 6 change the sign, and 2 is kept as it is. And our axis of symmetry is equal to the a, so x equals 6. and you have to write the equation x equals 6 because it's the equation of that line. If you just write axis of symmetry equals 6, that is incorrect and you will lose a mark for doing that. It has to be an equation x equals 6 or whatever your value is. So question B, our turning point, we're looking for A, B. So we're going to change the sign of the 3 to get negative 3, keep the 4 as it is to get negative 3, 4. And our axis of symmetry is the same as A, so x equals negative 3. And C, we're going to change the sign of the negative 5 to get 5, keep the negative 3 as it is, so you should have 5, negative 3. Remember your turning point does need to be a coordinate point, so both brackets and your x value and your y value. And then axis of symmetry, x equals 5. So last one, change this 4 to become negative 4, keep the negative 1 as it is, so you should have negative 4, negative 1, and then axis of symmetry, x equals negative 4. So really well done if you got all 4 of them correct. Okay, for this one, again for you to try, I would like you to write down the equation of the following graphs. So each of these graphs, you are given your turning point. Okay, so I want you to use your knowledge of what the turning point is to write down the equation of each of these graphs. Remember, it should be in the form y equals, in brackets, x minus a squared plus b. So if you pause here and give this a go. Okay, hopefully you've unpaused now and we can go through the answers. So our turning point is 7, 3. Okay, and the equation that we're wanting it to be in the form of is y equals x minus a squared plus b. So if this is our turning point, which is a, b, we are going to write down our equation. We're just going to replace the a with what we have here. So x minus 7 squared plus 3. So your first answer, you should have x minus 7 squared plus 3. The next one, this is your a and your b. So replace the a and the b into the formula to get x plus 5 squared plus 4. The next one, your a and your b, replace it into your formula, so y equals x minus 9 squared minus 3. And then the last one, y equals x plus 2 squared minus 2. So really well done if you got all of them correct.